Hello and welcome to another tutorial. We saw how to download GraalVM native image, and now let's look at more details about GraalVM native image. Now we saw that native image doesn't by default come with the GraalVM, and we saw that GraalVM is built on top of a JDK, usually Open JDK. And what it means is that it has the JDK, all the command line tools that come with the JDK also built in the GraalVM. But then it has some extra command line tools like GU, which was the Graal updater, and we use that with the install command to install the native image. And native image is an executable binary from bin folder inside libsvm. So when you install GraalVM, here I install, for example, GraalVM Community Edition version 11. The most recent version is 17, so I recommend you install GraalVM 17. And then in the contents home, there is a lib directory, and inside that there is a svm, which is called the substrate VM. And then inside there is a bin directory, and then native image is there. Now we saw that in the actual bin directory, which is inside the home directory, there is a symbolic link to this actual executable file, which is native image, and to the operating system or to the terminal, the executable binary and its symbolic links, they're equivalent, right? So usually you put your executable file somewhere, and you can create symbolic links to them and put them in different directories. So the native image compiles your executable class, a class that has the main method, and we have already seen this in the previous lectures. It can also compile the required JVM modules and also the garbage collector. So basically, when it compiles your Java application to a native executable binary, there is a JVM already compiled to native binary, and also it has all the necessary components like garbage collectors, etc. So you are still sure that if your Java application that was running on top of the JVM didn't have any memory leak or resource leak, once you compile it to native binaries, it will not have a memory leak as well. However, I will show you what happens when you compile to native binary, and the memory usage of your native binary after you compile Java application is much smaller than when you run your application on a JVM. That's just because how JVM requests memory from the operating system, right? So the memory footprint becomes smaller, and then the execution time or the start time becomes much faster. But then the question is, what's the benefit of the JVM? And we saw that previously. There are some benefits on running your Java application on top of a JVM, right? When you compare it with the native execution. And the main benefit is the JIT compilation, which means, first of all, JVM is lazy loading. It does lazy loading. If you have lots of classes on your class path but you never use them, JVM doesn't load them into memory. That's one thing. And then the JIT compilation, which is a dynamic compilation, happens at runtime, and it only happens for the methods that you mostly call, right? So a lot of methods in reality, they don't need to be compiled to native code, but then when you compile your entire application to native code, obviously everything has to be statically compiled. So at the end, it can create a native executable binary which has a much faster startup time. So it's very cool, right? Clearly, it has some limitations. There are a couple of limitations. We know that currently GraalVM supports Java 17, which is very good. It works great for simple Java applications, especially the Java applications that you develop based on like trying to develop a command line tool. The final executable binary is much larger than a jar file, which we already know that because the jar file is just the class files from your source codes. The JDK class files are not included in your jar file. But when the GraalVM native image compiles your application, it also includes everything, all the class files from the JDK, and even a JVM itself, right? A very compact version of the JVM and garbage collector. So when you compile your application, your native image could be 11 megabytes, whereas if you just package your Java application as a jar or executable jar, it could be just a few kilobytes, right? So the size different. But then the fact that even 10 megabyte of a size these days is very small file size, you really don't need to worry about the fact that native compilation causes a larger size. And in general, the native image at the moment has a very weak support or kind of non-existing support for the graphical tools that the Java provides, like the Swing or Java FX. So pretty much all the Java GUI frameworks at the moment are not supported, which means if you develop a Swing application, there is a high chance that it's not going to work after you compile it to native image. But again, for the command line applications, it works very well. If your Java application has a main method and takes some arguments from the user and then it does some stuff, you can definitely compile it to native binary and it's going to work much better, much faster with consuming less memory. For our simple Java projects, native image is a good tool for creating a native executable. Make sure the jar file has a declaration of the main class inside its manifest.mf file. So this is a topic we will come back and later look at it, but the idea is that so far we've tried to basically give the native image the class path and then also specify the main class, that the class that has the main method, right? So we run the native image on the main class, but you can also run the native image on a jar file. So you package your project as a jar file and then run the native image on the jar file. And in order to make it executable, you want to make sure that the jar file actually has a manifest file inside of it. And usually in the manifest file, there is a line that tells the whatever runtime that's running this jar file which class has the main method, or where is the entry point to the Java application, right? So jar is like an archive file, but then there is a file manifest.mf inside of it that tells that says which class has the main method, right? So you can also run native image on a jar file that has a manifest that points to the main class or main method, and then it can be compiled to a native executable binary. Alright, so we saw that how to install the default toolchain for macOS and other platforms, and then after that we saw that you go ahead and download and install GraalVM. On macOS, you have to make sure that in the recent version of the macOS like Catalina and the later versions, you need to make sure that you tell the operating system to not quarantine these GraalVM directories. So you have to remove that by removing the attribute recursively and in this home directory of the GraalVM, right? Just execute this command and give it the path to the GraalVM directory. And then after that, you run the Graal updater GU with the install command and tell it native-image. We saw this, and if you have already installed it and there is no newer version available, the GraalVM or GU update, GU just tells you that you already have installed the latest version. And then you can add the bin directory of GraalVM to the path environment variable. Remember that the bin directory already includes a JDK, OpenJDK itself, right? But my recommendation is that you always create a environment variable for the home directories. Like I have created an environment variable called Graal home. So you say export Graal home equals the path to the home directory of the GraalVM. And also I've created another environment variable Java home, which points to the JDK 17, for example, home directory, right? And then after that, what you can do, you can access the native image from Graal home /bin. So let me just quickly show you that. So if I open up a terminal and tell it echo Graal home, it tells me that it's set for the terminal to this path, right? The home directory of the GraalVM JDK 17. And if I say echo Java home, it tells me that it's set to the home directory at JDK 17. If I want to run Java or Java compiler or JVM from JDK 17, I say Java home /bin /Java, right? And then I can look at the version, and it tells me that it's Oracle hotspot. If I want to launch my Java application with the JVM that comes with the GraalVM, instead of telling Java home /bin /Java, I tell it Graal home /bin /Java, and you will see that this is the JVM that is built based on the OpenJDK 17 instead of hotspot, right? So hotspot is the Oracle VM. OpenJDK is the community version of this, the open source version. And then, but again, in the path environment variable. If I type java hyphen version, my terminal can also find a java. And if you look at my path environment variable, you see that basically the JDK 17 is the first that comes in the path, which means if I just type java, it's going to pick up on this version, java home, which is JDK 17 being java, right? So you can decide which JDK you want to use. The Open JDK 17 is basically compatible with Oracle JDK 17. So if you compile your Java application with the Java compiler that comes with the Oracle JDK, then you can compile that application to the native image tool that comes with the GraalVM JDK, right? So these are compatible as long as for both of them you use 17, for example, which is my recommendation. Now finally, we can also look at how we can execute GraalVM. So you say graal home /bin and then a native -image. That's the and then we can say hyphen version, and it is able to execute this native image from the bin directory of the Graal home. And then it tells me that GraalVM Java 17 community edition, and then everything works fine, right? Now if you want to compile, you have to tell it basically native image, and here you're going to tell native image the class path, right, that your application needs in order to that the native image also needs to know where all the class files are for your application. So you also specify the class path, and then after that you specify the main class of your application, and after that you can give it the name of so you see the class name and then the image name. So I can tell it let's actually go back to our Eclipse and then try to compile our native image again. So let's terminate this, go back to our Eclipse. So we previously compiled our hello class, but we run it from this directory. So right now we are in this test directory. If I just run the native image on the HelloWorld without giving it the name for the output image, it's going to create HelloWorld and put it in the same directory. But I'm not going to do this. So let's go one level up. All right, now we are in the super directory, or the parent directory. So I'm going to run the native image. So Graal home native image and then -cp, which is the class path, right? And then the name of the main class, but then you can specify the name of the output file, and actually you give it the full name, right? So right now this HelloWorld class is going to be found by the native image because native image searches the class path, right? Note that this HelloWorld.class is not inside the current working directory that I have in the terminal, but it doesn't matter because it searches all the directories that are specified in the class path. And after that, I'm going to tell it, for example, go to test2 and create an image called my app or my Java app or my_Java_app, right? What it does, it compiles your Java application and then puts the native image or the native executable binary inside the test2, and the name of the executable binary is going to be my Java_app. But then there are also other parameters like the options. So there are options that come in between your native image and the main class, and those are the options that you pass to the native image tool. Namely, mainly it's just the class path, right? After your main class and the name of the output executable, you have some other options, and these options are the ones that usually are passed to the JVM. So we can also try that. For example, at the moment our HelloWorld class accepts some system arguments, right? So we can see if we can set them here. So we can say -d name equals Bob, right? So let's see if this works. So we are passing some parameters or options to the native image, and then we are passing some parameters to our HelloWorld class, right? The main method of our Java application. And if this works, then every time we run our native executable application, these parameters are going to be by default passed to that application, right? So if you know that you always run your Java, your native executable binary, and you require that some system properties are be set by default all the time, then you can give them at the time of compilation. At the moment it didn't work, right? So there was an error linking the native image, and let's see what the error was. Let's see. So let's try to remove that and then see if this works. So let's see if this works. So right now we're not specifying any option, and in the future lectures I will show you what options are allowed here and what options are allowed here. So these are all in the documentations of the native image, and we will look at all the options and all the details. For now, we're trying to make sure that everything works fine. We can compile our application or Java application, and then we can also specify where to put the result of the compilation and what the name of the output file is going to be, right? And it worked fine. And as you can see, the compilation is pretty fast, just because it uses multi-threading. Therefore, it uses all the CPU power that your computer provides. So it's very fast. So right now, if I say ls test2, okay, so we actually put it in test3, I believe. No, so let's refresh. All right, so so it created a directory. Okay, so we made a typo here. Yeah, so let's go back. Let's delete this. Yeah, test2. So yeah, so we made a typo here. That's why if this directory doesn't exist, native image actually creates the directory and puts the compiled the result of the compilation there, right? So it's good. And then right now we're telling it, hey, compile this class file, this Java application that has this main class, and then put it inside this directory, and the name of the executable is going to be my Java app. And again, it's using all the CPU power of my computer, all the cores. That's why the compilation goes pretty fast, because so basically it mostly compiles the JDK, and because my application only has 3 class files, so it's pretty fast. Now if we try to say ls test2, and as you can see, I have my native executable and it's already named my Java app. So if I say test2 and then my Java app, it's going to work fine. And again, we saw that in the past that we can pass parameters, the command line arguments. Let's say -d name equals Bob. And as you can see, this system property is set. We're not passing any command line arguments, but we can do that as well. Hello, and then we have one command line arguments, hello, and then one system property, and these are some other stuff that our Java application runs. So I hope you enjoyed this lecture. In the future lectures, we will look at all the details of the native image. So please stay tuned, and I'll see you in the next one.